Welcome everyone to this Foundation for Water Research webinar, Pollution from Highway Runoff and the Strategies to Manage It. This event has been organised by the FWR, an independent community of professionals from across the water sector and related scientific specialisms. The community comes together for deliberative discussion to support the development of interdisciplinary solutions to water challenges, and the FWR community provides guidance and strategic thought leadership for the IES's water activities. I will shortly post a link in the chat where you can sign up for the free FWR newsletter. This will allow you to stay up to date with our kind of topical issues in the water sector, as well as our wider work. We are really delighted today to be joined by Jo Bradley, Director of Operations at Stormwater Shepherds UK. Jo has worked in the field of pollution control for over 30 years. She was at the Environment Agency for much of that time, working with various industrial sectors to identify pollution control and prevention best practice. In recent years, she's focused on urban pollution, particularly pollution from highways, and she joined the charity Stormwater Shepherds UK in 2000 and has been doing small amounts of research alongside many presentations, meetings with highway drainage professionals, and the development of guidance. The presentation will be followed by Q&A, so please do use the Q&A box, which you can find at the bottom of your screen throughout, and I will then read these out on your behalf later on. Thanks so much for joining us, Jo. Over to you.
Thanks, Ethne, and thank you very much for having me. It's a pleasure to be here. So, yeah, as Ethne says, I work for a small charity dedicated to reducing urban pollution. And some of you who have encountered me on LinkedIn before will know that I focus very much on pollution from highway runoff. And I suppose this is the reason why. This image on the right is a concrete slip form drainage channel. They are commonly used on newer motorways and upgraded motorways. This is a smart motorway scheme in Cheshire. They are designed to whoosh the water off the motorway as quickly as possible, because that's the function of drainage for highways, if you're a drainage design engineer. The problem with these designs is they do nothing for pollution control. So you can see the pollutants all captured there in the drainage channel, and all that will happen next time it rains is that will whoosh off that surface and straight into the local river. Most of the stretch in Lancashire especially has no treatment on it because it's an old motorway, and so that pollution is conveyed straight into the river environment without any treatment at all. And this problem has definitely been in the too hard box for a very long time, and I'm trying to drag it out, kicking and screaming, into the spotlight so that we do something about it. But it's difficult, it's going to be expensive, and we need to get our heads around that and do something about it. So when it rains and whooshes all that pollution out of that drainage channel, where does it go? And in this situation, this is the M62 in a place called Cleckheaton near Leeds. And this is where the motorway drainage rushes off into this little stream. And the pipe you can see in the middle of the screen is the eastbound carriageway coming into the river, and the pipe coming in on your right is the westbound carriageway coming in. And the reason I show this slide is this watercourse. This is legally a watercourse, and those of you who are familiar with the legislation will know that legally that watercourse should be clean and able to support aquatic life, and this one isn't and doesn't, because it's grossly polluted by motorway runoff. We've sampled some of these outfalls, Stormwater Shepherds and one or two others. I won't labour this because you may not be familiar with this level of chemistry. I'm not the chemist, but what this slide shows is that you can see in the column on the right the environmental quality standards and the maximum allowable concentrations. Those standards are set in law, and they're set to prevent acute pollution of the river environment. So those standard levels are set such that if they are exceeded, the aquatic environment is polluted with an acute level of toxic pollution. And you can see from that middle column where I've highlighted those cells in red, those particular chemicals fail the environmental quality standard significantly. One or two of those are hundreds of times above the limit. Those chemicals are polyaromatic hydrocarbons, and so they are part of the highway discharge runoff, and they come from your tyres and your exhaust fumes and unspent fuel that discharges into the water environment, and so they are coming off the road environment when it rains. The other pollutants that are in road runoff are equally concerning. Polyaromatic hydrocarbons have been the focus of my work for a while because that's where I started with the analytical results. But the other pollutants that are in highway runoff are definitely toxic metals, lots of copper and zinc. Copper and zinc are also poisonous to aquatic life. They are more difficult to measure in comparison with their environmental quality standard because it's an annual average. So you have to take lots of samples through the year to measure compliance against that annual average. And I haven't done that. But we know that they fail the environmental quality standard when we take the samples. The other thing that is in highway runoff, that is the new sexy new kid on the block, is microplastic tire wear particles. And there's an image there of some microplastic tire wear particles that a friend of mine, Florence, provided from Plymouth University. These are, the clues in the name, they're microscopic tire wear particles. They come off your tire when you're driving. They are a function of the friction between your tire and the road surface that keeps you safe. So they will always exist and they will always be produced. But they cause the most horrific harm in multiple ways. They leach out toxins. They carry toxins. So some of the tiny toxins like the PAH, you stick to them and they carry the toxins. But they also cause harm in their own right, physically. So they're ingested by aquatic and marine creatures. They fill up their stomachs, they choke them. Somebody showed some footage the other day of a microscopic worm that had ingested a microfiber and choked on it. But they also have now been found in the bloodstreams and the placentas and the brains of mammals and aquatic and marine organisms. So it's a it's a cocktail of grim toxic pollutants, really. I'm afraid I'm bringing to you rather a gloomy message today, just in time for Christmas. So yeah, toxic goo. The reason I worry about them, the reason they keep me awake at night is this slide, really. These toxic pollutants cause all sorts of harm to the creatures that live in our aquatic environment. So they cause mutations and deformities. They cause mutations at the embryonic stage so that creatures are deformed before they're even born or hatched, so that they don't thrive and feed and grow as they should. They disrupt cardiac function and bone and liver metabolism. They prevent effective reproduction. They prevent the effective act of reproduction, but they also cause abortions and eggs to fail. So they affect reproductive success in multiple ways. They're carcinogenic. They lead to failure to thrive. They also affect the behavior of these creatures. So they affect their ability to run away from predators, but they affect their ability to chase food. And if all that weren't bad enough, they can cause death. I mean, it's an horrific catalogue of harm that these pollutants are causing in our aquatic environments. And what we need to remember is that because they're suppressing our populations of these aquatic creatures, many of which are river flies, that then has a knock-on effect on the wider ecosystem. Because if the river flies don't hatch, then the things that eat the river flies also don't thrive. That's birds and bats particularly. And also the pollutants some of them are bioaccumulative. So if they're in the little insects in the river and then the fish in the river eat the insects and then the birds eat the fish and then things eat the birds, those pollutants bioaccumulate up through the food chain. So an horrific effect in the river itself, but also an horrific effect through the broader ecosystem. I've only got half an hour today, so I'm not going to go into detail. We have recently, this summer, published this report in partnership with CIWEN and the Reece Jeffrey Road Fund. And this report, you definitely need a gin and tonic in hand. It's not an easy read. It describes this level of pollution and the problem it causes, but it does give all the detail in that report if you'd like a copy. So just to try and cheer you all up a little bit, we're going to talk about what are the solutions. So this highway runoff is rushing into our water environments across country. There are 25,000 discharges off the strategic road network and probably 1 million total discharges of highway runoff. So we need to find solutions for treatment. So for the purposes of treatment, we break the pollutants down into suspended solids and dissolved pollutants because we treat them slightly differently. So the suspended solids are relatively easy to treat because they want to settle. If you give the highway runoff the time to rest, the suspended solids will settle of their own accord, and they're relatively easy to remove. And they bring with them all the most of the microplastic tire wear particles, most of the polyaromatic hydrocarbons, and most of the toxic metals. So removing sediment is your priority. But there are also dissolved pollutants. And I think this slide's quite handy. So this bottle on the left is a bottle of highway runoff from the London Road and going into Preston Town Centre. The bottle in the middle is the same sample, just a smaller aliquot of it. And then the bottle on the right is a sample that we have filtered through a 0.45 micron filter. So the gentleman I was with from Lancashire County Council was like, woohoo, we fixed it. And you look at it visually and you think you fixed it because it's so much cleaner. But then when you look at the results of analysis, you can see that you've still got 51 micrograms per litre of dissolved copper and 88 micrograms per litre of dissolved zinc. So you still, having treated that runoff, you've removed the sediments, you've filtered it through a small pore filter, and you have still got levels of toxic metals that fail the environmental quality standard. So it's important to remember that when we're trying to come up with solutions to pollution from highway runoff. So what are the options? So remember that this varies depending whether you're talking about really busy roads like trunk roads and motorways, or less busy roads like my cul-de-sac or the road outside your office today. The solutions will vary. And I'm going to talk for the next few slides about solutions to really polluted road runoff. We'll talk a little bit. I think I've got a slide later on when we talk about treating runoff from less polluted roads. So just bear in mind that these next few slides are for the really intensely polluted stuff. So you need sediment traps. You need some way of capturing that sediment. That's your most important task. Sediment traps, oil water separators, vortex grit separators, and filter drains are all options for capturing sediment. Once you've taken out most of the sediment, then you sometimes will have to think about removing some of that dissolved pollution that we looked at. So that would be stormwater filters potentially, and ponds and basins and wetlands. So what's a sediment trap? This is a huge sediment trap. So this is a sediment trap that National Highways built in a place called Stover Park near Exeter. And this is treating the runoff from the A38. And this is the first part of the treatment. So this huge sediment trap is where the sediment will settle out. So it's designed to let the runoff rest for a few minutes so that the sediment settles out. And that will work. It's quite an expensive solution because you can see it's quite big. Designed in situ, lined with concrete, and then vegetated around its margins, and then it will capture the sediment, but it's definitely an option. If you can't do that because you haven't got the space, then you might use a hydrodynamic vortex separator. And this is one that we installed a long time ago, actually, in a town called Wigan. But these are designed, this is like a Dyson cleaner for stormwater runoff. So if you imagine your stormwater runoff coming in from the left-hand side of that image, it goes into a spin and it spins around within the vortex grit separator. Most of the sediment settles out and goes to the bottom. And then the clean air water comes out on that. You can see the outlet there on the right and goes down into the River Douglas. That's taking out probably, it depends on the flow rate, but probably 30 to 40% of the pollution that's in that highway runoff. So these are a good option for locations where you can't do anything big and vegetative, but you want to remove some of the pollution. They're tested. This one is tested. It was tested in America, so they are known to remove a proportion of the sediment. It's proven, and they are. I like them because they completely isolate that pollution from the environment. It's like catching it in a big bucket. Once it's caught in there, it can't escape, and it's protected from the aquatic environment. So a good solution. Even better, and I get teased for liking filter drains. I love filter drains. This is a filter drain on the M6 toll road in the Midlands. The concept of a filter drain is that the road runoff goes straight into the filter drain from the carriageway edge and then goes down into the stones, and the sediment is captured in the spaces between the stone. So you've got a huge capacity for sediment capture along that length of road, because for every metre of road, you've got a metre of filter drain. So you can capture the sediment in the void spaces, and then you can add a layer. This particular image shows a layer of SDS Aqua Exchange, which is one of the products on the market. That's treatment media. So that then captures the dissolved metals. It's a bit like cat litter. And that's a layer that you can put underneath the stone that will capture the dissolved metals. And again, because you've got this device along the entire length of the road, every linear meter of road goes into 1 linear meter of that device, and the dissolved metals will be captured for probably 15 plus years before you have to do any maintenance, because you've got a huge capacity for treatment. I like filter drains. You don't have to have the that's a geocellular cell at the bottom for flood risk management, which you can include, but you don't need to include. When you've taken all the sediment out, or most of the sediment out, then we start to think about dissolved metals. This is a stormwater filter. So the water comes in on the right-hand side of that image and is discharged across the top of that yellow surface. This is a big thing. This is like 11 meters long by 4 meters in diameter. So it's a big piece of equipment. When the water distributes across that yellow surface, it then trickles down through the filter media, and that captures the dissolved metals. These are excellent devices where you need to capture dissolved metals, but they're big and they're expensive. So you only use them where you really need them. Not very many of these are sold in the UK market, but when you've got a particularly sensitive habitat like a stream with white-clawed crayfish in it, or a fishery or a marine protected site, then these devices can be really good to remove that dissolved metals load and reduce the pollution on the receiving environment. Once you've done all of those things, once you've taken out most of the pollution, then you can start to think about ponds and wetlands, basins, and vegetative treatment devices. In a pond like this one's on an industrial estate in Chorley in Lancashire, and this takes road runoff as part of a cascading basin system. And in there, you've got sunshine, which is breaking down some of the pollutants. You've got sedimentation, so the smaller solids will settle out in the bottom of that pond. The plant growth around the margins of the pond will take up nutrients. You get breakdown of organic pollutants by microorganic activity. You get volatilization of some, you get assimilation of others, you get precipitation of metals, lots and lots and lots of natural processes going on in that pond to reduce that pollutant load. But, this is quite a big but, the natural processes can only occur and creatures can only survive in that pond if you've reduced that toxic load first. So what we can't do is use ponds and basins like that and just put highway runoff, untreated highway runoff into ponds and basins, because it's too toxic. It's full of toxic sediment, pardon me, and it simply builds up in the pond and creates just this horrible toxic swamp that really can't support any life, and where natural processes can't succeed because the toxic load is too high. So you must have treatment upstream before you go into a pond or basin. And as I said earlier, it's better if you can, in fact, it's essential, I would argue, to catch the sediment somewhere where you can remove it cheaply and easily. This is an oil water separator, which is another type of device where you can capture sediments and isolate them from the environment. And this is a contractor emptying an oil water separator. This is a process that we're very familiar with in the UK. We have contractors, thousands of contractors who do gully pot emptying and sediment emptying and sediment trap emptying with these huge vacuum tankers that suck all the gunge out and suck all the water away. So this is a good option for capturing that toxic pollution and keeping it isolated from the environment. It does create waste. It creates hazardous waste. And people say to me, well, the more treatment you deliver, the more waste you will produce. And that's true. But I would respond by saying that this stuff doesn't belong in the environment, so we have to catch it somewhere and do something with it. And I agree that we need better waste management processes, but that's a whole other presentation for another day. This is quite a powerful image, I think. This is some of the contents of one of those separators that's on its way to be treated. This is the first step at the treatment facility. They take the water away. This is the sludge that we captured in a vortex grit separator discharging into the River Douglas in Wigan. This is one device. So if you imagine that there are, we think, 1 million discharges discharging highway runoff into the water environment, and every one of them discharges every time it rains. This is one device that we took 5 tons of sediment from. Just imagine how much of this black toxic sludge is going into our water environment across the UK every time it rains. And we've had some rain recently. So you have to think about How do we deal with this? How do we manage it? How do we take this out of the water environment? And then what do we do with it? So this is on its way to being treated. And how can we manage that effectively and cost effectively? And it's not easy. But what I did mention earlier was that it's easier for low trafficked roads. So this is Sheffield. I don't know if anybody is in Sheffield today, but this is in the Sheffield Grey to Green retrofit regeneration drainage system. This is a sustainable drainage system. This is a SUDS solution. So the runoff from this road, where you can see that blue car, just goes straight into that bioremediation zone. And because it's such a huge bioremediation zone in Sheffield and the runoff goes in, the pollution is distributed across the surface of that bioremediation zone. All those natural processes that I mentioned earlier will take place. So you've got plants growing, you've got sun shining, you've got microorganic activity, you've got sedimentation, precipitation, assimilation, all those things going on, all going on in that bioremediation zone. And so you've got the treatment you need for that road because the traffic density is very low. Those are fine for residential developments, roads in towns and villages, primary school car parks, all those sorts of surfaces where the pollution level is quite low, and they will deal admirably with that extent of pollution. So SUDs are fine, but only in the right place. And maintenance is still important. Somebody said to me the other week, well, maintenance, SUDs don't really need any maintenance, but they do. And we have to be honest about that and recognise that they need litter picking, they may need their inlets cleaning, they may need the soil changing in them every 15, 20 years if they're heavily loaded with pollutants, and the plants need looking after. So SUDs are fab, but we need to look after our SUDs. And then whatever you build, you must maintain it. I've spent a lot of time in the last 10 days talking about the failure to maintain SUDs. But this is an oil water separator. This has done a fantastic job. Everybody looks at that photo and goes, ooh, but actually it's done a fantastic job. It's caught all that sludge before it's gone into the water environment, and it's sitting there waiting to be emptied. And this was the beginning of the maintenance operation. So the contractor was just about to take all that sludge away. So an excellent device doing an excellent job, but only if we look after it. And everybody, I love this photo. Everybody knows. I could probably task you all with going out this afternoon and looking around where you're living or working, and you'll find a gully pot that looks like this. And we're just not maintaining our drainage infrastructure in our urban centres because we haven't got enough money. But it's a poor excuse, and it's unfair to expect our drainage infrastructure to function when we treat it like that. But this is going to cost a lot. A big treatment scheme for a motorway outfall can easily cost £3 million. That one I showed you at Stover Park with the big sediment trap being built, that was about £3 million because there's 2 sediment traps and 2 reed beds. They've got 25,000 outfalls on the strategic road network. So if anybody wants to do 25,000 times 3 million, I dare you, but it's a huge number. Local authority roads might cost less because their treatment schemes don't need to be as big. And you can use SUDs for most of them, and SUDs are cheaper, and SUDs deliver multiple benefits as well. So you can start to account for the multiple benefits, and that offsets the cost a little bit. But whichever way you spin this, you are going to be talking about millions of pounds every year for decades if we are going to truly fix highway pollution in British rivers. But, and this is a big but, keeps me awake, we've recently allowed or empowered our water companies to spend £56 billion, I think between now and 2050, reducing spills from storm overflows. 56 billion. But we don't really know if storm overflows are all causing that much pollution. Some rivers they are, absolutely, but in some rivers less so. And some of them spill into bigger rivers, tidal rivers, where they're potentially causing less harm. Some spill into little tiny tributaries and are definitely causing harm. But I would argue that we could split that 56 billion and spend some of it on highway runoff. I always say half, but that's perhaps a bit generous. A proportion of it on treating pollution from highway runoff, and obviously a proportion of it should be invested in helping farmers to reduce pollution from agriculture. At the moment, that's massively disproportionate because that's a huge amount of money to spend on one source of pollution, and we're spending nothing or very little on the 2 other primary sources of pollution in the UK. So I think we should redirect our investment according to the harm to river health. rather than the noise in social media. So where do we find all that money? Joe wants 28 billion quid or whatever to fix highway runoff. Where are we going to find it? Well, in Germany and parts of the US, they have a stormwater utility charge where you pay a fee based on the amount of impermeable surface in your property, which is definitely that fee is then creates a stormwater management fund, which the local authority uses to manage stormwater. So that would be the treatment of highway runoff, but also flood risk management, maintenance of infrastructure, conveyance, storage, attenuation, all sorts of stormwater management would be paid for by that fee. And I would love to see that in this country, but there is no appetite for new taxes at the moment. The other thing you could do is charge a fee on every tyre that's sold and every brake pad that's sold, because they're some of the sources of pollution, and perhaps an additional penny on every litre of fuel that's sold, so that you would have a fund then to deliver the treatment of highway runoff. That could work. It would be administratively quite tricky, but it could work. You could stick an extra 10 quid on everybody's road tax and create a fund that way. That might be easier to administer, and that would work too. And also there's a component in your water bill that pays for the conveyance and treatment of highway runoff, and maybe we could make that bigger and use that as well. So there are mechanisms available. They're just not very politically very palatable at the moment. So I challenge you to think about that and think about how you think we should pay for this. So I'm going to leave you with that thought. Follow me on social media if you're brave enough. If you're interested in the technical work, then follow me on LinkedIn, because that's where I share most of my technical stuff.
That's great. Thank you so much, Joe, for that
Thanks, Ethne.
presentation. That was
That's
really
fun.
interesting overview and a good focus on some of the solutions that we have to think about. So thank you so much for that. To all our attendees, please do put your questions for Joe in the Q&A box. We're going to kick straight off into the Q&A session now. So I wonder if you could reflect, Joe, a little bit. You talked through kind of various different solutions that you can use for highway pollution. Given climate change and its related increase in extreme weather events, do you know how some of these solutions will fare given changes in weather patterns and climate?
Yeah, it's really difficult, because actually generally speaking, we would design treatment schemes to treat the 1 in 1 year rainfall event. If you then have a 1 in 500 year rainfall event, such as we seem to be experiencing more often these days, then your treatment device a lot of that will bypass your treatment device. That's potentially not a problem because the river will be in spate. It's really difficult to know where to cut that cake. How much do you treat and how much do you bypass around the treatment device? But I think if we design it well, we can still do it. We can still do it effectively. But it's really tricky. And if you imagine the sort of rainfall events we've had recently, then all of a sudden your priority becomes flood risk management again rather than water quality management. And that is always a conflict. That's a conflict I experience all the time, is everybody wants to spend money on flood risk because they can see the harm that it causes. They feel it in their own homes and their factories and their journey home when the bus can't get through. But actually the water quality harm, nobody feels it. Nobody knows it's happening. It's not affecting you and I. It's not. It's even river swimmers aren't really conscious of it, and so we've got this ongoing problem of sort of poor perception, I suppose. And it's tough. It's tough to know how to design it.
Yeah, and I wonder, do you think some of the more kind of vegetative solutions you talked about, SUDs, could be good for those types of things, as they also can contribute to things like flood risk?
I'm going to say yes, but very cautiously, because um, the vegetative devices also need to be bypassed. So if you
Mm.
have a pond that's delivering treatment of highway runoff, then you will design a residence time. So you will say, we expect the pond to capture and retain the road runoff from a 1 in 1 year storm event or a 1 in 5 year storm event for 24 hours or 12 hours or whatever, in order to deliver the treatment. So all those natural processes take time. In best practice, you would divert any flows above that round your pond,
Mm.
because otherwise you're just whooshing all the stuff you've captured out of your pond, and also you're destroying the potential for those natural processes. So ideally you would bypass your pond at that point. Now, whether or not you'd have a sacrificial flood pond, which you could do, that would be ideal, but that would be additionally expensive.
That makes sense. Thanks,
Just
Joe.
need loads of space. That's what we need, Ethne.
Yeah, thanks. So in terms of some of the solutions that you talked about as well, do these work with microplastics, or are there particular ones that are better for microplastics?
Frankly, we don't know a lot yet. National Highways did some research about 2 years ago and showed that ponds and devices upstream of ponds are effective in capturing microplastic dye particles. Quite effective. I think some of the research at the moment is suggesting that if you have a treatment train with a sediment removal device and then a pond or a wetland, you can remove over 90% of the microplastic dye particles. So it does seem that the sedimentation focus of the treatment schemes that we design anyway are going to remove those microplastic dye particles. So I think what I don't want to do is wait for more research. I think we just forge ahead delivering solutions, and then if needs be, tweak them in the future. Something we're not using yet, and I think we may need to use in the future, is flocculants. So you can dose the highway runoff with flocculants upstream of your treatment scheme, and that will enhance the flocculation of the particles and the sedimentation. And I think if we're focusing on microplastic dye particle removal, then flocculant dosing might be a trick that we haven't tried yet.
Right, thank you. That's really interesting. And what happens to the sludge and materials collected from sediment removal devices? Do they go
Oh,
to wastewater treatment works, or is there a risk of these being recycled back into the environment, or are they dealt with
oh,
in another way, like incineration?
yeah, no, they're hazardous waste, so they don't go back. They do not go to the sewage. I mean, some highway runoff does go to the sewage works because some highway runoff goes to the sewer. But when it's been captured in a treatment device and that sludge is removed, it goes to a licensed waste disposal, well, licensed waste treatment facility. It has to be treated, and ideally, the treatment would render it non-hazardous, but it would still end up in landfill. It can be incinerated. It's got quite a high rubber content, obviously, and therefore it can be incinerated. Um, I'm not an expert on waste treatment, which is the best solution. I'm not sure. There are problems with tire particles because they go up into the atmosphere as well as going down into the drainage. So if you look at soils alongside roads, you find microplastic tire particles in the soils that have been deposited atmospherically. So that's a problem. I don't know how we fix that. Uh, but also you find microplastic tire particles in sewage sludge because of the road runoff, and then that's disposed to agricultural land, and it all goes around in circles. So,
Right.
sorry, bit gloomy.
It's fine, thank you. Um, and if highway pollution is propelled by the use of fossil fuel-enabled vehicles with toxic waste from exhaust systems, do you think that the move towards electric vehicles will help with some of these sources of pollution? Obviously, things like tyre wear are slightly different.
Yeah, absolutely. Don't forget there are polyaromatic hydrocarbons in tyres, so some of it comes from tyre wears. Although, the composition of tyres is changing, and that should be removed. So yes, electric cars will remove that risk or minimise that risk. There is talk of electric cars being heavier and producing more tyre wear particles, although the jury's out on that a little bit because apparently the way you brake and drive an electric car reduces um, sort of friction. Apparently we drive them better than we do our normal cars. So the production of tyre wear particles might be similar. Um, and ditto the braking. I'm told that because you have this regenerative braking or something, it reduces wear of the brake pads. I don't know. It's the jury's out a little bit.
Thank you. And you talked through a kind of different mechanisms for funding some of these changes. How can local authorities be encouraged to pursue water and quality improvements at the moment? So what funding sources are actually available at the moment for reducing highway pollution?
Frankly, there's no specific funding mechanism, but what they can do at local authority level is and this is what a lot of them are doing, is they piggyback on other things. So active travel, so when they're changing road layouts to deliver active travel schemes for cycling and walking and similar, they can incorporate sustainable drainage systems into that. And a lot of local authorities are doing an excellent job of that. Whenever they do roundabout improvements, road widening, junction improvements, all those sorts of things, then they can include sustainable drainage systems when they restore or rebuild the road at the end of those. And they're doing a lot of that. Some local authorities like Enfield are just doing opportunistic suds installations whenever they can. And they're doing work in London with Cadent and other service providers saying when they dig up the road to put a new gas main in, they either retrofit suds above their gas main or they fund the delivery of suds adjacent to their gas main. So there's some good examples of that work as well. So local authorities have to be really savvy and find sneaky, cheeky ways of getting these things delivered. There isn't an explicit funding stream.
That makes sense. Thank you. And I have a question here saying, are national highways starting to come to the party when dealing with the pollution that is discharging from the strategic highways network? But also I have a comment from another person saying, I'm a project manager at National Highways in the Northwest, currently working on 5 outfalls, where at each location we're installing 1 to 2 vortex separators at each outfall. And they're saying, you're right, the maintenance of these is equally as important, and we need to make sure we design and install easy access as part of the works. So partly answering that question, but I wondered if you wanted to talk any more about National Highways and their role.
Yeah, I mean, National Highways, this is their bag. It's their road, their strategic road network belongs to them. They have a water quality plan. I have been poking them with a sharp stick for a long time, saying that their water quality plan isn't ambitious enough. They proposed to deliver 3 schemes in 2023-24. Well, they've got 25,000 outfalls, so that's not fast enough. So I'm trying to encourage everybody to move faster and potentially do what that contributors just mentioned, put vortex separators in. They're quick and dirty and they don't deliver full treatment, but perhaps that's the best thing to do, is to deliver some treatment at lots of outfalls rather than full treatment at a few outfalls. That's a discussion that National Highways need to have with the Environment Agency, because that's a regulatory decision. But National Highways, I talk to them, they talk to me, possibly slightly reluctantly, but there's definitely moves afoot to improve that design guidance, make that design process slicker.
That's good to hear. Thank you. And just going a little bit back to the basics of highways pollution. Obviously, we've mentioned tyre wear a few times, but where do some of the other pollutants, the heavy metals, all of those types of things actually come from? Is it from things like fuel spills, or what is the mechanism for those getting into the water system?
The metals mostly come from your tyres again, and also brake pads, brake dust. When you apply your brakes, you create brake dust, and when you apply your clutch, you create clutch dust, and those both contain toxic metals and some of the pollutants. But also your exhaust emissions, as your exhaust emits spent exhaust fumes, they settle on the road surface and that washes off. And also your exhaust, unfortunately, does emit unspent fuel, and that settles on the road surface. You also, if you've got a catalytic converter, there's some of the material from your catalytic converter going onto the road surface. And there are also things like screen wash and car cleaners and hydraulic fuels and lubricants and all the other sort of things that are associated with cars. There's also, in some European countries, they do research into the pollutant load from your road furniture. So your central reservation barriers were historically made from galvanized metal. So you've got zinc washing off your central reservation as well. And we have massive levels of aluminium in road runoff. And somebody said, well, it comes from your engine block. I hate to think my engine block's dissolving. I don't know about you. So I hope that's not the case, but there is a lot of aluminium in road runoff as well. So multiple sources, I'm afraid.
That's interesting. Thank you. We've got someone here as well that said that they did a dissertation about urban runoff and identifying non-exhaust emission tracers. Is there a good place where they can connect with others in this niche to kind of build their network? Are you aware of any networks in this area?
Probably not, but I'd be happy to talk to them, and we could perhaps talk about other people who are working in that sort of area. There's still lots of research going on, so perhaps it would be an academic group that you'd want to join. But I'll think about it. Get in touch. In fact, while we're chatting, I'll put my email address in the chat.
That's great. Thank you, Jo. And would there be a benefit to focus treatment on first flush events for rainfall after dry spells?
I don't like first flush on motorways, indeed first flush on roads. The problem with roads, particularly motorways and big trunk roads, is that your first flush, if you want to call it that, might last for 3 hours, because your pollution is travelling from the very top of the catchment all the way down to your outfall, and that might be 3 kilometres. It's got a long way to come, so it's not like a school playground where it rains hard and it washes the playground and everything's happened within 20 minutes. It's much different to that. So the pollutants mobilize at different rates. Some of the dissolved pollutants move more quickly than the sedimentary pollutants. Some of the sedimentary pollutants come in a whoosh at a certain rainfall event because they come out of the gully pots. The pollution lasts for ages. The polluter graph may come after the hydrographs. You might get a pollutant peak. So I try not to talk about first flush when we're talking about highway runoff. It's a bit complicated and it can distract people from good design.
Okay, thank you. And this is a bit of a technical question, so yeah, I'll see what you think about this. But metal filtration devices would also work with hydrocarbon containments. Could these then be substitutes of oil separators?
No. So you can have them downstream of your oil. You have to take the sediment out first before you try and take the dissolved metals out. But absolutely, you can filter out some of the dissolved metals. That's what those treatment media do. They are ionic exchange devices. So they're not filtering the metals out, they're capturing them through ionic exchange. So that's what you need to do. You couldn't filter the dissolved metals out because they're dissolved. And there's very, very small material. If you try and filter down to a really low um, microns, so 20 micron, if you try and filter down to the 20 micron particles, you can't because there's so much of it, it just blinds in moments. We had a 0.45 micron geotextile membrane wrapped around a filter once that we tried to put into a highway discharge from a car park in Wigan, and it blinded within about 10 minutes. And so you just can't filter road runoff because it's too grossly polluted.
Great, thank you. And last question today. Thank you for answering so many questions, and thanks to all our attendees for putting them in. But you've mentioned a few different metals, zinc, copper, and aluminium. You did as well. We've got an attendee who's also mentioning lead. Is this also a key pollutant from highway pollution that needs to be dealt with?
Well, lead was banned in petrol probably about when I was born, quite a long time ago. So lead levels have, and there's lots of research to show that lead levels decreased dramatically and quickly after that. I do still find a little bit of lead. I think I experienced a lead failure at some point somewhere, but it's certainly not a priority of the treatment work these days. We tend to focus on copper and zinc because we've still got huge levels of copper and zinc. They still fail environmental quality standards. There's also quite a lot of attention on things like rhodium, platinum, and palladium. I have to remember those because they're precious, but they feature in highway runoff. We get others. We get chromium and cadmium. We get lots of metals at significant levels. I have had a cadmium EQS breach as well in one of the samples of highway runoff that I took. So lead is in the mix, but it's far less important today than it would have been 30 years ago. But yeah, it's still in there and it's still harmful.
It's great. That makes a lot of sense. Well, thank you so much, Joe, for taking the time to present today. That was really interesting and a really useful discussion to have, as you say, for this kind of neglected area of pollution in waterways. So thank you so much for joining us. Thank you to all our attendees as well for coming today and putting your questions in the Q&A box. You can actually find all past webinars from the FWR on the FWR website and the YouTube channel. If you're watching this and you are an IES member, don't forget to record your attendance using the CPD tool in the members area of the website. And if you're not a member but you've enjoyed today's webinar, please do consider joining the IES. For now, a massive thank you to Joe. Thank you to everyone for attending. Have a great rest of your day. Thank you.
Thank you, everybody.